All right, welcome to the 6.2 video. Example 1 is comparing integers on a horizontal number line. So the first thing that you need to know is that on a horizontal number line, numbers to the left, okay, so if I have a horizontal number line like this, numbers to the left are less than numbers to the right. So in other words, if this is 0, and I talk about the numbers this way, those are going to be less than, okay? And the numbers to the right of 0 are going to be more. Numbers to the right are greater than numbers to the left. So let's do an example. If I gave you compare 2 and -6, it would look like this. We briefly talked about putting on a number line, putting on equal intervals. So we're going by ones here. What I'm going to do is I'm going to try and find where I'm going to put 2 on my number line. I'm going to put -6 on my number line. So I'm going to start with 2. So I put a solid dot like that. And then if I'm graphing -6, I put a solid dot like that. So what we realize is that 2 is to the right of -6. So 2 is greater than -6. Okay, we compared those by using a greater or less than or equal sign. And this is telling us that 2 is greater than 6 or -6. Remember, we always talk about money. If I'd rather have $2 than owe somebody $6. All right, example 2 is comparing integers on a vertical number line. Something to keep in mind, because with example 1, we had we had a horizontal number line, which would go left to right, and when we have a vertical number line, it goes up and down. So you got to remember that when you're working on this one. So using a vertical number line, we're going to compare -5 and -3. So I'm going to first start with drawing out my number line, make sure it goes up and down, and then I'm going to graph -5, and then I'm going to graph -3, and then I'm going to compare them because that's what it's asking me to do. So looking at the two of them, we have to realize that -5 is below -3. And remember talking about that language of below, above, etc. We need to recognize that -5 is below or is less than -3. Again, look at it as money. I'd rather owe you $3 than owe you $5, so making 5 the lesser of the number. Example 3 is ordering integers. So my directions say to order -4, 3, 0, -1, -2 from least to greatest. So we're going to graph each integer on a number line to start off. Before I start putting my marks in, I've got to recognize the fact that I've got 3 as a positive, I've got -2, -1, and -4 as negatives, and 0 should be right about there. So I need to make sure I go past -5 or -4, and I need to make sure I go past +3 on my number line. So I'm going to set my number line up like this, and then I'm just going to start putting them on the number line. So I'm going to start with -4, just graphing them, then 3, 0, -1, and -2. And then after we do that, we're going to write the integers as they appear on the number line from left to right, because we learned up in before example 1 that on a horizontal number line, numbers to the left are less than numbers to the right. So we just start kind of jotting them down. So the order should go -4, -2, -1, 0, and 3. And this would be my final answer for a problem like this. Example 4 is reasoning with integers, and I wanted to do this one this way just so I could kind of explain what was happening. So first of all, it says a number is greater than -8 and less than 0. What is the greatest possible integer value of this number? So if we want to know what the greatest is, we could put -8 and put 0 on a number line just like they did here. Let me grab my pointer here. Okay, so the number is between -8 and 0. So you put -8 on your number line, put 0. So what's happening is it's saying the number is greater than -8 and it's less than 0. So the number must be to the right of -8 and to the left of 0 on a horizontal number line. So if this was a multiple choice problem and we had A is -10, B -7, and C -1 and D 2, the study tip over here kind of gives us an example. It says you can eliminate choices A and D. A is -10. We know that because it's saying that the number is greater than -8. If it's greater than, it's going to go to the right. -3 is greater than -8. I'd rather owe somebody -$3 than -8. So that means it's greater, it's going up. So we can eliminate -10. We can also eliminate D as 2 because we know that it's less than 0. Well, less than 0 goes to the left of 0. 2 goes to the right. So we already know that we can X out D and we can X out A. The next part, we've got -7 and we got -1. So here's -7, and I'm just going to put that in a different color on the number line that we're kind of talking about, and we have -1. So those are what we're comparing. So the number must be to the right of -8, to the left of 0. Both of those hold true. The greatest possible integer value between -8 and 0 is the integer farthest to the right on the number line between these values, which is -1, because it says, what is the greatest possible integer value of this number? -1 is the greatest possible number. Again, I'd rather owe somebody $1 than owe them $7. So you got to kind of think of it in a real-world application if you can. All right, we have example 5, our last one, real-life application. It says the diagram shows the coldest recorded temperatures for several cities in Virginia. So this is the outlined state of Virginia right here. Okay, and they're telling us the coldest temperatures. Which city has the coldest recorded temperature? It says graph each integer on a vertical number line. So I want you to take for your notes for this one, I want you to take and draw out this vertical number line here. And I want you to put these points that they're talking about on the line just like this. So you're copying that down. Go ahead and pause it and do that. Okay, after you do that, we have to look back at what the question says. It says, which city has the coldest recorded temperature? What we can notice is that on our number line, the coldest, and this is nice with temperatures because we realize when something's negative, it's really cold because we deal with that in Michigan. So -12 in Richmond, Virginia is the coldest recorded temperature. And we know that because it's negative. So then part B says, has a negative Fahrenheit temperature ever been recorded on Wallops Island? Explain. So we're going to look at Wallops Island. It says 0 degrees. It says the coldest recorded temperature on Wallops Island is 0 degrees, which is greater than every negative temperature. So a negative temperature has never been recorded on Wallops Island. You just got to kind of know, like, thinking about negatives versus positives and what that actually means, especially when it comes to these real-life applications. All right, the next part is a try it. All right, the try it is from page 257 in the book. You're just going to do that. Well, it's on your own. Order the integers from least to greatest. So what you'll need to do is either do a vertical or a horizontal number line to show your work. I'll do one of each for the answers, but they should still be the same. All right, go ahead and pause it at this time so that you can do your work and then see the answer. And here are your answers. I did one as a horizontal number line and I did one as a vertical. You could have done either or. And that concludes our 6.2 video.